Alright, so I took down my last video on how to attach a skinned mesh render to a skeleton, so for example a shirt, onto a body and get it to animate with those bones rather than supplying it with, or rather than it having its own skeleton. I took that video down because I made the assumption I was working under where I had to prune the bones that were not weighted was false. The engine doesn't work that way, and so I took the video down, but then someone reminded me that there's no other content on the internet on how to do this, so I figured I'd upload a new one showing you the right way to do it. It is very simple, very short, but it's so poorly documented out there that it's not surprising that no one knows how to do it, or that nobody even pointed out how incredibly wrong my last video was, because it's so poorly documented and so poorly explained. Alright, we're gonna create a new project. I tried to do this in the existing game I was making, but it's just so messy. Like, there's so many other systems that control like how to store them, how to reference them, put them together, so we're just going to create a blank project really quick. I'm going to bite the bullet and just create a blank project. Alright, here we are. Let's go ahead and get a ground. Create a quick ground material. Alright, now that our Unity project is set up, we need to get our character in game. Now, this is the actual character that I use. This is a quick little test shirt that I threw together really quick, and this is the rig that it's attached to, that it animates with. I want to go over something really quick. It's useful to have a reference like this to the whole body in one mesh in the game, and in fact I'm actually going to use that, and I recommend you use it as well. It's a really easy way to get access to all the bones, but you would never want to actually render this whole body in game. What you would want instead is to break it into body parts. So for example, I've got just the elbows here, just the feet, just the hands, just the head, just the hips, so on and so forth, because when you've got a shirt on the character, right, you don't want to be rendering the chest. So let me show that shirt really quick. There we go. Maybe let me see if I can get it to clip. There we go. Okay, so you see how like part of the upper chest is cutting through the shirt. Not only that, the upper chest and the stomach and stuff is all being rendered, right? Every frame the GPU is figuring out what the new positions of each vertex is, what the lighting is, all this crap that it just doesn't need to do because it's covered up by a shirt. So if you've broken your whole body mesh into parts when you equip this shirt, you could simply, remove the shoulders, remove the upper chest, so on and so forth, because that stuff doesn't need to be rendering underneath the shirt. Alright. But for the sake of demonstration, I'm going to keep this very simple, and we're just going to use a single full body mesh. I just wanted to give you a quick heads up that you should not actually be doing that in game unless you're doing a very, very simple game. Okay, so first thing we need to do, I'm not going to walk you through how to make a mesh. I'm not going to walk you through how to rig it, all that stuff. That's on you. That's beyond the scope of this. I'm just showing you how to get the mesh attached to the skeleton in the Unity engine. So first thing we're going to do is we're going to get the body and the rig, and we're going to export that as one thing. So file, export as an FBX. Let me see here. I'm going to set this to Unity. The important things in here are that you limit to selected objects. Let's see, path mode off, auto, batch mode off, transform, make sure your scale set right. If you keep your scale to 1 and you don't mess with your scale in Blender, it will be correct for Unity. You want to apply all scalings. Forward should be -Z, up should be Y up, apply unit, apply all this crap, geometry, smoothing. I use face, but there's other smoothing methods depending on what you want to do. I'm using like a super flat stylized thing, so face works for me. You might want to use normals. I don't know of any time you would ever want to use edge though. Export subdivision, probably not going to be doing that. You definitely want apply modifiers. That's a very important one. Yeah, you shouldn't need to do any of this. You can triangulate faces if you're having issues where it's not rendering correctly, but you shouldn't need to triangulate them in Blender. Unity is pretty good at triangulating the meshes that you import. You shouldn't be messing with vertex colors, the armature. This is important. The bone axes are important. You want your primary bone axis to be Y, your secondary bone axis to be X, but you can change those if you've changed the way your bones work, but definitely your primary bone axis is going to be Y. The X or Z is up to you based on how your bones are rotated. So you can see I got my X pointing up so that the arm rotates on the X axis, so that makes my secondary axis X. The bone is along the Y axis, so that makes it the primary, the Y. If your Z axis was up here, then you would want your secondary axis to be Z. I think that's how that works. I may be totally wrong on that, and if I am, I apologize. You want only deformed bones. You should not need leaf bones. Unity does not need leaf bones. And then the animations, it's up to you. How you want to do your animations. If you want to use NLA strips, you can use that. I don't use NLA strips. I use actions. And then you also want key all bones. All right, we're going to call this the body test. No exclamation. Export. Okay, and we're going to do the same thing for the shirt. So I'm going to hide the body. I'm going to select just the shirt, and the armature. You want to export it with the bones. If you don't export it with the bones, the weights will not go with it. So if you look at your shirt, right, you've got all these vertex groups. If you don't export it with the skeleton, these vertex groups and all the bone weights will not go with it. So select your shirt and your rig, export, FBX, and this one will be shirt test. Okay, let's get these into Unity. We're going to throw body test in here. And we're going to throw shirt test in here. Alright, so body test, we're going to use animation type generic. I have a lot of problems when I use humanoid. If you use humanoid and your bones aren't rotated or set the exact same way that Unity expects them to be, it will just rotate them so that they are. So your fingers will bend, sideways or whatever. I don't really like to mess with it. I leave mine as generic, and I just make my own animations. You would only ever really need to use humanoid if you want to use the built-in Unity tools for like retargeting animations, and their IK system might use it, but their IK system is fucking garbage. Do not use the Unity IK system. You're going to want to buy Final IK. That's really the only good IK. You can write your own IK, but it's a little iffy. I've written my own IK in the past, and it's just not as good as what Final IK can do. Avatar, I'm going to create from this model. Let's see, root node is going to be root bone. There we go. And that really only matters when you're doing root animation, I think. Anyways, skin weight, standard 4 bone. You can leave that as 4 bones. So this is where, I'm going to pause for a second and go over this. This is where the issue from my last video came from. I did not understand how the skin weights standard 4 bones works. I thought that if you exported a pair of shoes and it came with every bone, all the bones in the hands and the head and the hair and all that stuff, I thought it would be checking weights for all those bones. It doesn't work that way. This skin weight right here, if it's set to 4 bones, every vertex in that mesh, so for your boots, for example, every point on your boot would have 4 bones that it references every frame to check that bone's position and rotation to figure out where that point on the mesh, that vertex, is supposed to go. So it doesn't matter if your skeleton has 1,000,000 bones or 10 bones. It takes the exact same time to deform the mesh, because the mesh doesn't care how many bones you have. It's got its own little list of bones that it checks. So the whole point of the last video was to prune out all the bones that have 0 weights. You don't need to do that. The engine does not function that way. It's much smarter than that. Okay, I'm going to go ahead and apply this. I think that's all I need to do here. And then the shirt test, I don't even think you need to set the avatar, but I'm going to. But I don't think you need to. Okay. So let's get the body in the game. There's the body. And let's get the shirt in the game. I think they need materials. Yeah, they need materials. Let me make a material really quick. Okay, so I've got the shirt in game and I've got the body in game. Looks like the body's already got an animator on it. Let me make a quick animation controller for it. Alright, and I should have an animation in here somewhere. Stand, fall, F. That should have some stuff going on. Okay, let's see. Hook that up and hit play, see what happens. Now these animations are made for VR, yes, you can see this isn't going to be super good because the upper body is not animating. You know, let me just make a quick animation for this. And this will actually be really good because the animation won't be on the shirt. So you'll be able to see that the shirt will use the animation that's on the skeleton. Alright. So it's going to do this funky stuff. That'll be a good test of whether or not the shirt is animating. Re-export the test body with the new animation in there. Let's get back into Unity. Delete the body test. We don't need it anymore. Because, oh, actually, you know, it would have been cool. I can show you how to overwrite one. That's all right. There we go. Okay, but so it did kind of work. So if you open and you go to your Unity project, this is just a little sidebar really quick, because as you're doing this, you're going to need to iterate, you're going to find a problem, and you're going to need to redo it. You're not going to want to rebuild the animator every single time you do this. You don't have to, right? So if you've built your animator with your walking cycle, whatever, and you just want to update the mesh, like you messed up something on the mesh, or you added a bone or whatever, it's very easy to do. You just go into your project, into the assets to wherever it's saved. So bodytest.fbx is here. I could just create a new body test, like so, character, Unity, and then I would just copy this over without deleting it from here. Leave it in here, and I would just copy it over, and it would say, hey, this already exists. Do you want to overwrite it? Yes. When you go back into Unity, because Unity keeps a .meta asset for each thing, so yeah, bodytest.fbx.meta. This file, it compares these two. This meta file just tracks whether or not this file changed, and it will recognize that, hey, there was a change here, and it's going to re-import it, and it's not going to break anything else. Your animator will still work, all your scripts will still work, everything will be the same. It'll just use the new updated one. Now, it's not 100%. If you change something that it was trying to reference and it's no longer there, or it's in a different spot, you can break some stuff, but this is an easy way so that you don't have to redo your walking cycle or whatever. If you make an animation thing with like a locomotion cycle and a jumping cycle, you don't have to redo it every single time that you add a new animation. For example, if I add a jumping animation in there, I can just overwrite that body test with the new one that has the jumping animation and just add the jumping animation, and it will work. Now let's go ahead and attach this shirt to this body. So you see we just brought the shirt test in, we imported it, it has its own skeleton on it. We don't want to use this skeleton because the body also has a skeleton. So right now we've got two whole skeletons in the game, and that's not what we want. If we take a look at this shirt test, right, the object itself, the parent object, shirt test, is just a transform. There's nothing on here. Under that, we've got the IK rig. This is the full skeleton. And under that, we've got the shirt test. This is the game object that has the skinned mesh renderer on it. This is the only thing that we need, is this component. We don't need the skeleton. We don't need the parent object. So we're going to write a script here, create C# script, and we will call this attach mesh. Okay, and let's go ahead and add that to the body test. There we go. Attach mesh script. You know, let's do that in a different spot. Let's attach it here. Okay. Now in the attach mesh script, let's see, what are we gonna need? We're gonna need our skinned mesh renderer. Call it shirt, and we'll make it public, and then private transform array bones. Now we need this bones because we have to supply the shirt with the bones, and then we also need a public transform root bone, and we're going to give it the root bone as well. So let's go ahead and set up the root bone. Let's see, the root bone should be the IK rig. I think that's what it's using. Root bone is root. Okay, never mind. So it's under the IK rig. Root. This is our root bone. You can see right here it says it'll tell us what our root bone is. That's another advantage of bringing in the mesh. It clears up that ambiguity. Is it the parent object of the skeleton, or is it in here? Because I mean there's more bones. There's these drivers under here. So bringing in a mesh will just tell you this is your exact root bone. So now that I know that, I can use that. Up here, attach mesh. So my root bone, I know to just give it that root bone. There we go. All right, then we've got our skin mesh renderer shirt. We're going to attach that later. Actually, let's go ahead and do that now. Let's delete our shirt from the scene. Here's the shirt that we imported. Now remember, the parent object is just a transform. We don't want that. What we want is this, the skinned mesh renderer. We don't want the animations, we don't want the material, we don't want just the mesh, we want the skinned mesh renderer. Now you can use just the mesh. This is what I'm using in my game. There's some more flexibility you can have if you use just the mesh, but it's much simpler to use the skinned mesh renderer, especially if you're not going to be changing any of this stuff at runtime. Much simpler. So it's on here. There we go. I can just grab this and drag it on there. Like so, shirt test. All right, so we've got our shirt test skin mesh renderer assigned, and we've got our root bone assigned. Let's go ahead and get this attached. So in start, we need to populate this bones. So bones equals game object dot get component. And we want the skin mesh renderer dot bones. So what that's doing is that's looking at the object that it's on. We attached it to the same object where our mesh is, and we're just getting the skin mesh renderer dot bones. So we're attached here, we're attached to this full body M. It's also got a skin mesh renderer component, so it's looking at its own game object, and it's getting this, and it's getting the bones, which we can't see here. The bones itself is hidden, but there is a hidden array of transforms in here called bones. And we need a reference to that, so we're just getting a reference to it. And now we want to attach our shirt, so we're going to create a function void attach shirt. There we go. Oops, like so. Okay. And then we're going to call attach shirt. There we go. That attach mesh was this. All right, so in our attach shirt, what we want is we're going to create a new skin mesh renderer. New shirt equals instantiate skin mesh renderer of our shirt. That should work. So this will create a new game object, and it will attach a skin mesh renderer component to it, and it will make that skin mesh renderer component our shirt that we have saved. Okay, and then new shirt dot transform dot parent equals, let's go this dot transform, so it'll be a child of the body, the game object that holds the character's body. And then we need to do, actually we can wait on that. First thing we need to do is we need to get the bones. So new shirt dot bones equals bones. So that's the bones we copied from the character's body. And then root bone, new shirt root bone equals the root bone that we've saved from that, again, we got from our body. And that should be it. I'm pretty sure that's all we need. Let's see if that works. Let's go with our animator. Where did we put that? Is it even hooked up? Do I not have an animator? Am I blind? Okay, I'll just do that. Avatar, none. Oh, that's right. Body test, generic avatar, create from this model. I have to redo this because I re-imported it. Root bone is root. Okay, apply. There we go. So now we've got an animator back on there. Okay, use that. All right, let's open that animation controller, delete this guy, we don't need that anymore. Let's put our test anim in there, and let's set it to loop as well. Okay, I guess I gotta do it through here, animation. Where's my test anim? There we go, select test anim, loop, loop pose, and that should be all we need. Here we go. We got our guy doing his funky thing. The shirt, which you remember didn't even have this animation on it, it's now bound to the skeleton and it's animating with it. You see we've got our body here, full body M, that's the body mesh, and then we made our shirt a child of it. Shirt test. It's got its skin mesh renderer, it's got its root, and off it goes. That's all there is to it.